All right, guys, welcome back. We got another lesson today, 13-6, Law of Cosines. In the previous lesson, we learned how to solve triangles with the law of sines. However, there are situations where the law of sines cannot be used. If you have side, angle, side, or side, 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 so if you have two sides and the angle in between them, if you have all three sides but no angles, you have to use what we call the law of cosines. And again, this is something you guys probably learned back in geometry, but we're going to review it again today. This is probably the last lesson because the law of cosines seems to be the most complicated of the three, or the two, I should say, but what's nice is it always works. There's not that ambiguity that you can get with the law of sines. What does it look like? It looks like this. A squared equals b squared plus c squared minus 2bc cosine A. B squared is a squared plus c squared minus 2ac cosine B, or c squared equals a squared plus b squared minus 2ab cosine C. So basically you've got these three sides and the angles opposite, just like in the law of sines. We have these three formulas. They're also in your note packet right here. We have all three, and depending upon which angle you have and which sides you have, that's going to determine what you do. So if you do have an angle, like in this example here, we have this angle's 82 degrees and we have the two sides, so we have side, angle, side, basically. You use the law of cosines once, and what we're going to do here is we're going to use that to find side B up here. So I'm going to say b squared is 6 squared plus 10 squared minus 2 times 6 times 10 cosine 82. Take the square root of the answer, and you get b is about 10.9. Once you've done that, now you can go back to the law of sines, which is a whole lot easier, to find the measure of angle A. And I'm going to point out here, notice how they've written this like so. They've got this fraction inside the inverse sign. Do that. You don't want to start rounding until the very last minute. So just use your parentheses. They're your friend. Work it out on your calculator this way. You get the angles about 33 degrees. And then all you got to do is subtract from 180 to get the third angle. Here we have another example very similar to that one. We've got angle A is 46. We've got B is 9 and C is 7. So I'm going to find A. So A squared is going to be 9 squared plus 7 squared minus 2 times 9 times 7 times the cosine A. On my calculator, when I work that out, I get that A squared is about 42.5. So it's really 42.47304, blah, 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 blah. If I get the square root of my answer, and I get that A is about 6.5. So once I know A is about 6.5, then I can go to the law of sines. And I can say the sine of 46 over 6.5 equals, say, the sine of B over 9. So that means I'm going to do inverse sine of, let's see, 9 times the sine of 46 divided by 6.5. That's going to give me it out here. 9 times the sine of 46 divided by 6.5. Close up my parentheses. Inverse sine of that is about 84.9. So B is about 84.9 degrees. So then, to find C, measure of angle C, I'm going to do 180 minus 46 minus 84.9. is about, and I have to say about because I rounded, 49.1. Now, if you only have sides, and I'm going to show you another example where you only have the sides. That is part example 1b in the textbook. You're going to have to use the law of cosines twice. If you have an angle, you use it once, and then you jump to law of sines, and then you subtract to get the third angle. If you have all three sides, you're going to have to use the law of cosines twice to find two angles. Generally, we go for the largest angle first, and that's always going to be opposite the longest side. So they find the measure of angle C is about 84.7, and then they use it again to find the measure of angle B. It's about 31.6, and then they subtract both of those from 180, and they get 61 degrees, approximately. So, let's go back to the note sheet here to see what else we can do. There's another thing that's interesting. It's called Heron's formula. And you can use Heron's formula to find the area of a triangle if you have all three sides. And it kind of works with, it's kind of derived from the law of cosines. Basically, it's this. If you have all the sides of a triangle, you don't need to find the height and the base to find the area. You could say it's 1/2, S is equal to 1/2 the sum of the sides, so half the sum. So then the area becomes this, the square root of S times S minus A times S minus B times S minus C, where S is half the sum of the sides of the triangle. So if you want to find the area of this triangle, you could drop a perpendicular and work some stuff out. Or you can find the sum of the angles, the perimeter, add them all up and divide by 2. So the sum of the angles, or I'm sorry, the sum of the sides divided by 2 is 38. So then I can plug them into Heron's formula. I'm going to say 38 is equal to 38 minus 27 times 38, or 38 times 27. Let's start over. Area is square root of 38 times 38 minus 27 times 38 minus 31 times 38 minus 18. Square root of 58,520, so about 242 square feet. Here we have the three sides. They're meters. Let's see, A is 9. It would help if I was using an actual pen instead of a highlighter still. A is 9. B is 12. C is 7. So let's figure this one out first. 1/2 of 9 plus 12 plus 7. Let's see. 9 plus 12 plus 7 divided by 2 is 14. So then I will do the square root of 14 times 14 minus 9 times 14 minus 12 times 14 minus 7. So that would actually be the square root of 14 times 5 times 2 times 7. Which is 980. Take the square root, and we get about 31.3 meters squared. Heron's formula. So, if we go back here, here's some other examples here. A Coast Guard patrol boat and a fishing boat leave a dock at the same time on the courses shown. The patrol boat travels at a speed of 12 nautical miles per hour, and the fishing boat is at 5 knots. After 3 hours, the fishing boat sends a distress signal, picked up by the patrol boat. So the fishing boat's going kind of southeast, the patrol boat's going kind of northeast. If the fishing boat does not drift, how long will it take the patrol boat to reach the fishing boat at a speed of 12 knots? All right, so if we draw a diagram here, what we get is this triangle. We know that the fishing boat has gone 15 knots. It's going 5 miles per hour, 3 hours, 15 knots. We know that the patrol boat has gone 36 knots because it's going much faster. We need to figure out this side. So we can use the law of cosines to figure that out. How do we figure out this degree measure? Well, we've got 15 degrees this way, we got 130 this way, so just subtract, and the angle measure right here is 115. Work it all out, D is 44.5. So divide that by 12, it's going to take them about 3.7 hours to reach the boat. Now that's assuming there's no drift. That would be tough. But anyway, so then here we have another example of Heron's formula. That's especially useful if you happen to live in a triangular house or you're doing blueprints or something. You work out Heron's formula like I just said. There it is. So there's the law of cosines. It's a little bit complicated compared to the law of sines, but it always works. As long as you have the sides or you have side angle side, you can do it. All right, so I hope this helps. And if you learned something, smash that like button, and I will see you in the next one.